Ladies and gentlemen, we are going to do our nomenclature, and it's different on test 2 than nomenclature for all other tests you've had. This is the format. This is it. Stretch it out a little bit. And when you're doing this, the motto you should have is this motto. I'm stealing from history. K-I-S-S. Now, you're not going to get me in trouble for writing out what this means, because I'm trying to help you. Anybody know what it means? It's good. She said it. Yes, James Carville was advising Bill Clinton for his re-election, I believe. And his advice to him was, keep it simple, stupid. Because Clinton loves talking. I don't care if you're Democrat or Republican. You just look at Clinton. The man's got a gift, okay? And he'll just go on and on. But his advisor wanted him to keep on topic. So this is for you. The last part is not for you. No, that's why I said the last part is not for you. She was asking already, are we stupid? No, you are not. You wouldn't be in this room. But this is advice of you talking to yourself. You don't have to be that mean to yourself. Okay? Don't come up with a big molecule, please, here. As simple as possible. In fact, try to base everything on the same carboxylic acid unless you're told you can't. So my favorite's acetic acid. It's just simple, right? So I'm basing everything that I can here on acetic acid. So CH3, and I want to write it here with its name so that you know how that name changes when we name different functional groups. Okay? So we're going to draw an acid halide. So what do you change in that acid to make it into an acid halide? What do you get rid of and what do you replace it with? OH is replaced with a halogen. We like chloride because it's the popular one we use all the time, right? Yeah. This is one similar to what we just did. And are you surprised that it changes to acetyl chloride? Anybody surprised? So what's the system for changing the name of a carboxylic acid to an acid halide? You change ic acid to ill halide. Remember that, please, because we're going to do it again, but we're told which acid we have to use this time. Nitric acid. Yeah. And sometimes I do this, and I don't want it to be a surprise. Sometimes, I do this, show all pi. Because I do want you to show me, what nitric acid looks like, or the ester of nitric acid. So that started out like this. And it's got an OH. Got a plus, and it doesn't have two OHs. No, Dr. Whitaker, careful. It's got one OH. Yeah, it is a zwitterion if you want to go by the strict definition, right? Remember what zwitterion means? Just trying to get a minus so I can read here. Yeah. Adjacent atoms with plus minus? Yeah. So how do you draw the structure? That's the first question. What do you get rid of? Because I'm going to draw that first. What am I getting rid of? Yeah, I'm going from acid to the halide. So here's the acid going to the halide. Get rid of the OH. Yeah. Keep everything the same other than that. And put a halogen there, right? Follow the rules exactly. This used to be nitric acid. What is it now? Nitrile. Just follow the rules exactly. Lose the ic acid, replace with ill chloride. Exactly. Very systematic. Okay? And acid anhydride, I'm going to make it both parts of the anhydride symmetric, both from acetic acid. It didn't say draw an asymmetric anhydride. See how there's two acetic acids in there? Yeah. Acetic acid becomes acetic, sorry. It's still got its O, right? Acetic anhydride. Oops. Anhydride. So this time we kept the ick. So a little blue underlining. We got rid of acid and put anhydride in its place. See that? We kept the ick because we kept the O. That kind of makes sense if you're trying to keep track. Cyclic acid anhydride using adipic acid. Oh my. Why did I say oh my? Adipic? Oh my, such good. Apple! Apple is adipic. So how many fingers are in the air for oxalic acid, which is the O in oh my, such good apple pie? 2. So I got to get to adipic by saying oh my, such good apple pie. Right? Oh my, such good apple is 6. 6 carbon diacid. You have to learn it. They're called acids to die for. They're in the textbook. They're diacids, okay? They're in our notes from previous days. 2, 3, 4, 5, 6. There's adipic acid. Oh, he wants to make a cyclic anhydride. Please don't use 2 adipic acids. I don't want 2. There's 2 acids in adipic acid. How big is the ring going to be? Remember, one of the O's ends up in the ring. How big is the ring? I think it's 7. O ends up in the ring, ends up connected to the other carbonyl. 2, 3, 4, 5, 6, 7. So we're drawing a ring size 7 with an O in a corner. And it's got carbonyls on each side. That's what makes it an anhydride. And that's 3, 4, 5, 6, 7. You like it? One, 2, 6, 7, 5, 4, 3. Good. Yeah. And guess what it's called? It's like the one above it. Right there. Good stuff. Nitrile. Anybody know what a nitrile is? What's a nitrile have to have? Nitrogen, yes, I have to agree. It's got a nitrogen with a triple bond to carbon. Wow. Yes, nitrile gloves are a polymer of polyacrylonitrile, I believe. That's why they're called nitrile gloves. Acrylic acid being, somebody asked, is that what nitrile gloves are? That's why this came up. There is acrylic acid. This is not related to this activity, I'm sorry. And there is acrylic nitrile, and you make a polymer from that, and it's called polyacrylonitrile. Now, sometimes it's an ester of acrylic acid, and I believe that would be more accurate for you, derivative to make polyacrylonitrile. Here are nitrile gloves. So, not relevant to this one, but it came up. And the C-triple-N we saw, that's the relevant part. And guys, keep your life simple. There were 2 carbons in acetic acid, right? This is based on acetic acid. So that's not the answer, but that's what it's based on. Watch the naming. You keep the ACET. You lose the ic acid. You put O-nitrile. It's very Scottish. Acetonitride. So acetic acid became O-nitride. Is this molecule news to you? I hope not. That was the one used in chapter 9. It's the best polar A product solvent to do an SN2 reaction. Well, it's the best in many circumstances, let's just say. It's also the most expensive one. Polar A product solvent, right there. Now my big question for the chapter, what the heck is that molecule doing in chapter 18? What's the title of chapter 18? Yes, carboxylic acid derivatives. It looks nothing like a carboxylic acid. What makes it a carboxylic acid derivative? I can see every other example being a carboxylic acid derivative, can't you? I mean, wow, they still have the carbonyl here. Just change an OH to a Cl. Same story there. Oh, what about here? Oh, I still have the carbonyl and I put 2 acids. Carbonyl still here. Well, there's no carbonyl here. How can it be a derivative of a carboxylic acid without carbonyl? Oh, it makes me so happy when people read. Yes, some lectures in the past I would go on and on for like 10 minutes trying to drag that out of somebody, and she said it. Everything on this page has a carbon with 3 bonds to more electronegative elements. That's what makes you a carboxylic acid derivative. If you are a carbon with 3 bonds to a more electronegative atom or atoms, you're a carboxylic acid derivative. You got 2 bonds to O, bond to Cl. 2 bonds to O, bond to Cl. Oh, you're saying nitrogen and chlorine have the same electronegativity. It's based on carboxylic acids, the definition, okay? So let's just stick with the carboxylic. There you go. 3 bonds to O, 3 bonds to O, 3 bonds to N. More electronegative than C. Winner, winner. And draw and name an ester. Oh, we've been doing that for a long time, and my lab students can shine today. I'm going to let them shine. There's a reason I chose that R group. Got 2 people in the room, 3 people in the room, 4 people in the room. Made this yesterday, right? Let me, you made it last semester, didn't you? Or whenever we took lab together, right? 5, you're in the lab. So we got half the class in lab here. Okay, so what's this thing called? Oh, wow, she went all the way there. I like it. So a lot of students are saying, what the heck? Yes. You can call it isopentyl. Now, I don't think we would lose as many students by saying that. But I think the other students who are seeing amyl for the first, oh, shame on you if you think it's the first time. I'm just saying that now. I realized in chapter 7, there was a sec isoamyl group attached to boron. Oh, it's not new. So once again, a total aside, but we like to link things that we've seen before. Here is a sec and an isoamyl disec isoamyl borane. So yes, we're supposed to know amyl is a synonym for pentyl. Learn that because it's in some pharmaceutical names. Amyl. Okay. So what did we do to the name of acetic acid to make it into the ester name? The green underlining is unfortunate. I'm going to get rid of it. Just to make it a different color. That was just to show you amyl and pentyl are synonyms. The green is, well, acetate should have been in black. It's new. So what did you do to the end of ic acid? You got the ic acid became 8. That's the fate of the acid. Now, how do you name the carbon group attached to the alcohol? Like, what system did you use to come up with that name? You just name it as a group? Isn't that the name of a group we've been using since Orgo 1? The amyl's a new twist, but it's just ill. It's a group. So alcohol portion is the blue portion, and it goes first, and it's just a group. The ester from the acid is at the end, and the ic acid became an 8. It's kind of like an anion, isn't it? But you know it's not an anion. It's named like it's an anion. Is an acetate an anion? Named like that, but it isn't that. You know it's not an anion. Look at it. Okay? All right, now I want a diester of phosphoric acid. Ladies and gentlemen, if you don't know how to draw phosphoric acid, you must learn it now. Okay? It's going to come up more and more in your future. I snuck one on the board the other day. Didn't I have ATP on the board for 10 seconds? So here is phosphoric acid. You got to know it's got 5 bonds to O. 3 of them are OHs. And phosphorus can go beyond the octet rule because it's in row 3, right? So while we're here, look for phosphorus on the periodic table and tell me the Roman numeral on the column above it. What Roman numeral is above phosphorus and nitrogen? V, that's 5. What's above sulfur? 6. So when you're having trouble remembering how many bonds to oxygen a sulfate has, periodic table reminds you, 6. That's the most bonds you can make to that atom. Once you get past row 2, that's a new guideline you can use. How far can you extend the octet rule? Up to your group number. If you need to. Why need to? I got rid of, there's no charges there, right? Yeah, it was to get rid of charges that I went beyond the octet rule. Okay, so just trying to help. Sulfate, 6. Phosphate, 5. They're both common ions. Diester, what do you think I'm trying to get at there? Not just one ester. Two out of the possible 3, right? There's 3 OHs there. They're acids, right? So I'll take 2 of the H's off. I'm going to redraw the O's in a different color because they really come from the alcohol. And those are, what groups did I choose this time? The blue groups? Okay. Ethyl, phosphate, but you got to tell me how many ethyls there are this time. 2, yeah. So I'm just doing the system here. And you put a di in front. It doesn't mean it's a diethyl group, right? There's no such thing. There's 2 ethyl groups on a phosphate. Okay. What the heck is an amide? We just did one? We just did a secondary amide. You're right. I forgot about that. Here's my CH3 carbonyl. Here's a nitrogen. There you go. I like ethyl today. I don't know why. Check out this name. Acete is now acete. Acetic acid is now acete. amide. Acetamide. Now, what's that group on nitrogen? Yeah. Want to see how to say that? Watch this. This one's one word. So get used to the prefix N. It is what it says it is. I'm going to put a group on N. That's new. It's not revelationary, is it? Makes sense? And I'll do a quick example to illustrate. Why not? Let's put two different groups on the nitrogen. And this is just an aside, more practice. Longest chain is 1, 2, 3, 4. So what acid was that? Butanoic acid became butanamide. Sorry, I reversed the color scheme. And just to make it an even better example, there you go. So there's two ethyl groups now, right? N, 3 diethyl. Oh, it's treated just like a number. That's all. Glad we did this, huh? N3 diethyl and N isopropyl. Uh-oh. Think thin. Okay. Isopropyl if you're having trouble reading that. Good stuff. Almost a long activity, huh? That's a double if I ever saw one. You don't have to put that on your quiz or activities. Draw and name a lactam with an R stereocenter. Oh my goodness. I can't use acetic acid because a lactam cyclic ester, as hinted at last day. I'm pretty sure we talked about these just for a second. So come up with a nice, we want to do a beta lactam? Why not? Oh, whoa, sorry about that. Should have made the square first. Okay, that's a beta lactam. We'll talk about why in a second. There's no stereocenter. You guys put a stereocenter in. I'm going to put it here because there's something about lactams and lactones, which I didn't put on this activity. But after you learn lactams, you're going to learn lactones on your own. They're not cyclic. Oh, wow. There was a mistake here. These are cyclic esters. What is a cyclic amide? Clearly, that's not an ester. Help me out. What is it? It's a cyclic amide. I don't know why I did that. Too much going on. That's what's going on. So how do you keep it straight? Cyclic ester is a lactone. Cyclic amide is a lactam. Well, it's got am in it. That's how I would go. It's got am in it already. It's got to have a nitrogen. No nitrogen in lactone. Doesn't sound like a nitrogen's in there either. I want to point out, before I name this thing, I want to point out where it came from. Okay? It's like, I don't know. You probably won't like seeing this. What's that mean? Like, where did it come from? Yeah, I knew we'd have a cringe moment there. We're not going to do a retrosynthetic analysis. Do not panic. No, it doesn't come from a nitrogen there. Comes from a carboxylic acid. That's why we're talking about it. And it goes here, here, NH2. Oh. One, two, three, four off the ring. 1, 2, 3, 4 off there. And this thing is the parent. The parent. You got to name this thing. And you're not used to this at all because is there a ring in this thing? No. Longest chain is here. So it's heptanimide. That's not the whole name, but it's getting there. What carbon is the nitrogen on? It's a 3-heptanimide. Yeah. And the stereocenter is R or S. I believe it is S. It goes 1, 2. And it's got all the carbons. That is not a group. That blue thing is not a group, is it? Normally, sticking off a ring, you're thinking about group, but that's not how you name these lactones and lactams. They're named after the parents, where there was no ring. Okay, that's the parent. Has to be a carboxylic acid to be the parent, right? Okay, S3-heptanimide. You can also call it S-beta-heptanimide. What's beta mean? Next alpha. Where's alpha? And I'm going to go with the black, the blue here. That's alpha, that's beta, and that's where it's closed up into a ring, isn't it? So beta lactams, gamma lactams, delta lactams, epsilon lactams. Yeah. You'll notice on the exams, there's always the Greek alphabet along the side of this page, top to bottom. The whole alphabet they're used. Sometimes it's a short version if you don't need the whole alphabet. Okay. So if you forget the order, it'll be there. And was that our last one? Finally? Think so? Which one? Oh, we didn't do an image at all. I forgot we're still in this area. Yeah, I'm glad you're paying attention. This, just trying to make sure you know that's all for that guy right there. And an imide is like an anhydride, but a nitrogen in the middle. So we're going to go back to simple. CH3, C00, N in the middle between two carbonyls. And you can probably guess the name. You keep the acete. When it was a amide, you put amide. When it is an imide, you put imide. End of story. And I'll just put that in some other. There. Oh, I didn't do an R stereo center. Oh, I'd lose a half point on my own test. She asked a good point. I didn't, right here. Yeah, I was supposed to do an R stereo center. I did S. What's my fix? Clearly, I got to fix the name. But what's the quickest way to fix a wrong stereo center? Yeah, I'm just going to make that a wedge and make that a dash. Doesn't that fix it for me? Yeah. Yeah, I needed it to be R. I didn't read my question carefully enough. Now it's R. Good stuff. Thank you for picking me up today, guys. And we're going to stop and end.